esterification reaction. If you remember from your high school chemistry classes or previous chemistry classes, esterification reaction is reaction where an organic acid reacts with an organic alcohol to form an ester. In this experiment, we'll be synthesizing isopentyl acetate from isoamyl alcohol and acetic acid. This ester is known for its unique smell, that it smells like a banana, and for that it's called banana oil. However, the problem in esterification is that all reactions in the esterification process are in equilibrium, and equilibrium reactions that doesn't usually go to completion. Because of that, we'll be using the concept of Le Chatelier's principle of mass action to get our ester in the process. So this is done. So according to this principle, you can add more of the reactants, or you can remove any of the products in order for reaction to shift it to the products. So usually you can add one of the reactants. In this case, we have the acid and the alcohol, but because we have both the opportunity to add both, we can think smartly and choose to add the acid instead of the alcohol. Why? Because the acid is less expensive compared to the alcohol. In fact, we're also adding sulfuric acid in the reaction as a catalyst, because it helps to facilitate the reaction. What specifically the sulfuric acid does, we have a separate slide for that, and we will be discussing at the slide. So in this synthesis, we do also add sodium bicarbonate and anhydrous magnesium sulfate. So the magnesium sulfate is just drying agent to dry out the water, but the sodium bicarbonate and water are to wash out our remaining any excess of alcohol or acid remaining. Specifically, sodium bicarbonate should remove any excess acid or alcohol remaining in the reaction flask. So after drying with the anhydrous sodium or magnesium sulfate, at the end of the process, the ester will be more purified by distillation steps, and to make sure that you have synthesized the ester, you can further conduct IR and see that you have recovered the correct ester. The procedure is very direct forward. The acid we're adding as a catalyst is to protonate the carbonyl carbon in the acetic acid, and then when this carbonyl carbon undergo resonance, the carbonyl carbon of the carbonyl compound will end up having a carbocation, having an electron deficiency, and the alcohol will act as a nucleophile and attack that deficiency, and then we see rearrangement of the alcohol hydrogen to one of the OHs in the process, and that is just to make the water more or better living group. And then again we will have a delocalization. Before that we will have removal of the water molecule, and then when you deprotonate this intermediate, you can have the ester formed. By the way, this is an esterification reaction between acetic acid and ethanol, given to you as an example, as an easy example. In a similar way, our esterification reaction between our isopentyl alcohol and acetic acid is conducted. There is not any difference. So we have the alcohol and the acid. When we add the strong concentrated acid, the H coming from the strong acid will protonate the carbonyl carbon. We will have a resonance, and then a carbocation will be formed. The alcohol will attack the carbocation and gives us an intermediate. When we deprotonate this intermediate, again it gives us a neutral product, which is semi-product. Again, we can protonate by the axis acid remaining, and this is to make the one of the hydroxyl group to be more better living group, the same as we discussed it in the previous slide, and the water will remove easily, and then a carbocation will be created because of that, and this carbocation can undergo resonance with the carbon and oxygen, and finally by deprotonating this intermediate we can have our isoamyl acetate, our final ester. So the other thing is summarized here. We have our alkaline acid and our product ester and the water byproduct. So the principle, you can add more of any of the reactants, or you can remove any of these products. So if you choose to play with the reactants, like we said before, you can add one of the reactants. In this case, you can take the opportunity to add which one is appropriate to add. So having that these reactants have similar opportunity to be added, you can choose to add the acid instead of the alcohol, simply for cost purposes. And whereas if you choose to operate the reaction with respect to the product, the recommended way is to undergo distillation immediately while the reaction is ongoing. Okay, that will help us to remove, to distill the ester quickly while the reaction is undergoing. Then that will make us to have the product in the process. in this experiment, we'll try to apply both principles. How? This is how. So when we add excess of, because in the procedure we'll be adding acetic acid 3 times more excess than the alcohol, and again the sulfuric acid is not only acting as a protonating agent to make the carbonyl carbon more reactive, but also it reacts with the byproduct water molecule, changing it to hydronium ion. And because this reaction is irreversible, there is no any water, or there will not be any water left in the reaction chamber, which means there is high tendency for the reaction to go forward. So adding the acid is playing with reactants, and removing the products is an approaching with the products which we are applying it here. Sorry. So so I know that you have read your textbook, and if you find a different procedure with respect to your textbook, is for you to take the correction. So in this experiment we'll be taking isoamyl alcohol or isopentyl alcohol, and 0.03 moles of this alcohol will become 2.64 grams in mass, or 3.26 milliliter in volume, whereas we'll be using the acetic acid, glacial acetic acid, in 3 excesses, like it will be 0.09 mole. So you can follow the procedure in the textbook. The only difference is that you have to use the amount recommended here. And we are then in the important step of the esterification process. So the overall reaction happens in a reflux, and to do the reflux, first you have to add your reactants into the round bottom flask, and you can add the recommended reactants in the recommended amount, and also add 3 boiling chips, because we'll be heating the round bottom flask, and these boiling chips should prevent bumping. And then attach your condenser. Make sure that you can use any condenser. It could be a once condenser or a distillation column for that matter, but whichever you add, you have to make sure that the condenser has water in it, in fact cold water in it, and also try to make sure that the water inlets and outlets are tightly connected. And before you even start the heating, try to check that the water is flowing slowly in the condenser, and water must in from the bottom and must exit from the top, so that the cold water will take some time in the process. Sorry. I'm having a problem with my throat, so if you hear weird sounds, apology for that. So while we heat, the appropriate temperature is very critical, and when you assemble this reflux, you can put your heating source on the top of a ring clamp, so that in case you notice any overheat, you can easily remove this heat source and recover your samples safely. Remember that we're using acetic acid, which is known to be very volatile and very irritant also, and we're also using sulfuric acid, one of the most strong acids, and you must handle any of these acids with a great care. So in measuring the acids or the alcohol, if it is possible, weighing is more easy and more accurate than measuring volume, because when we measure volume we have to worry about the meniscus. You have to locate the meniscus correctly in the measuring cylinder or in whatever measuring apparatus you're using. And it's sometimes difficult to measure 3.27 milliliter in such a way. So if you can make it by weighing, we recommend you to weigh. Similarly, we will be using 0.4 milliliter of sulfuric acid, but it is very difficult to measure this amount of sulfuric acid, so you can use drops, and one drop is approximated to be 0.05 milliliter. When you add 8 drops, it means you have reached 0.5 milliliter. Again, try to add the drops using a glass pipette than a plastic pipette, so that you can make uniform drops. You can also control the dropping more than using the plastic pipette. So once we are done with the reflex, what we do, we just cool the reaction mixture in ice bath, and then we proceed to the washing step. In the washing step, we'll be washing them with distilled water, and to do that, you first have to transfer your sample into separatory funnel, and then certainly there may be some traces remaining back in the flask that are along with the boiling chips, and then you can add 5 milliliters of distilled water into the round bottom flask and reknead the flask and add that water into the separatory funnel, and try to shake it gently so that the washing will be effective. The next step is to wash with sodium bicarbonate. The sodium bicarbonate removes the excess acid, any excess acid or alcohol remaining, and to do that, you can add your add the sodium carbonate solution, about 5 milliliter, into the separatory funnel from the previous experiment, from the previous slide, from the previous procedure, and then allow this to stand for some time so that the carbon dioxide will escape from the separatory funnel, and then you can close the separatory funnel, make some shaking, and you'll see 2 layers form, and the top layer is an organic layer and the bottom layer is an aqueous layer, you can then remove the bottom layer and proceed to the next procedure. And then in this procedure, it's just to dry and transfer our sample. And you can transfer the sample from the separatory funnel into beaker. And of course, if you're concerned about the yield of your product, you can choose to transfer it to a test tube instead of a beaker. But whichever you use, you have to transfer it nicely, and then make sure that before you transfer, you have added your drying agent, sodium anhydrous sulfate or anhydrous magnesium sulfate, and then try to swirl the beaker or the test tube so that the dehydrating agent absorbs maximum of the water. And then you can go to filtration. You do the filtration so that you can isolate the dehydrating agent, and try to do that in a fluted filter paper. And again, still there is a concern about the yield. So when you do the filtration, try also to renew the beaker with 2 milliliters of pentane so that you can maximize your yield. This pentane will be finally removed by distillation, which it will skip out at only 336 degrees Celsius, whereas the final product ester will be obtained at 142 degrees Celsius, so that we will have two products here at different temperatures, and for that matter we have to use two different containers or two different test tubes, and you can collect them. You can collect the alcohol, the alkane first, and then the isoamyl acetate. Here, in order to help you measure, know the yield of the ester, you can pre-weigh the test tube or your container so that you can deduct the mass of this container from the mass of the container with the mixture, and you can get the accurate yield of your experiment. Good tip here is, when you make the distillation, try not to distill to dryness, otherwise the ester and the alcohol, both of them are highly volatile and you may lose them in the process. Well, that's all I have for the experiment. Again, as usual, if you have any comments or any questions on the lab lecture, you're free to ask me anytime. You can do that by putting comments on the YouTube, or you can email me too. And thank you.